Hi guys, this is a review of the workbook pages. I provided pages 163 all the way through page 169. You don't have to do pages 163, 164, or 165 because all the answers are in the book a little bit later on, but you're more than welcome to do them. I'm not going to go over all these questions, but they're really good, and there's some really good stuff in here. The reason I'm doing all these workbook pages for review is because it kind of covers everything. The weather map symbols that are on the bottom of page 13 in your reference table are really an overview of all the things that we've covered in meteorology. And you'll see that as I go through these questions. So let's start here on set 2. And again, if you didn't do set 1, if you skipped over this, it's a worthwhile thing to go look at. Okay, and you can check the answers out later. So number 17A is a question about air masses. And you'll see that the one is labeled MP right here. Now, if you forget what MP stands for, no worries, because it tells you right here in your reference table that MP stands for maritime polar. It's down there on the bottom, maritime polar. So what does maritime mean, and what does polar mean? Well, polar, I think you can probably guess, means cold. Okay, so it's a cold region. And if you look at the choices here, well, central Canada is cold, and the Gulf of Alaska is cold. So those would probably be your choices. The other two are not cold. So what does M stand for? Well, M, the maritime, means marine. It means water. Think maritime is water. Okay, so we're talking over water, but over cold water. So where would that be? Well, it wouldn't be in the middle of Canada. It would be the Gulf of Alaska. So the answer to this question is 4. Okay. All right, 17B. Which type of front and frontal movement is shown on the weather map? So this front right here, what is that? And if you're not sure, it's right here on page 13. These little triangles kind of look like icicles if you flip it upside down, and therefore you know it's cold. Okay, now which way is that cold front going? Well, the arrows point in the direction that it's moving. Okay, so it is moving this way, and that would be to the southeast. And so we know it's a cold front moving southeast, so that would be number 2. Okay. The MP air mass is identified on the basis of its temperature and what? Well, we know that the P stands for polar, which means cold. So that's the temperature. The M, the maritime, is referring to where it started over water. So whether it starts over water or over land is related to what thing on this list here? Is it related to wind direction? No. Is it related to cloud cover? Not exactly. Okay. Is it related to moisture content? Yeah. How much moisture is in the air is related to how much is evaporating. Okay. And so we have a lot of evaporation off the ocean, so it would be really, really humid. So this is the answer right here, number 3. It doesn't have anything to do with wind speed. Okay. All right. 18. An air mass classified as MT usually forms over which type of Earth surface? So MT, M standing for maritime, remember, or over water, and T stands for tropical. Okay, and if you didn't know that, it's right here, MT, maritime tropical. Okay, so where would that be? Well, it's got to be warm, right? So we know tropical is warm. And it's got to be over water because the M stands for water. So that would be the ocean. So that would be number 2. That was a pretty simple one. Okay, 19. What is the visibility in miles shown on the station model? Well, you got to figure out which one of these numbers refers to the visibility. If you're not sure, you look here on the station model explanation. It says visibility is this middle number right in here. Okay, so we know that this visibility is 1/2 of a mile. And so the visibility here is this middle number. That would be 10. So the answer is number 1. Pretty straightforward. Okay. Various weather conditions at LaGuardia Airport in New York City are shown on the station model. What were the barometric pressure and the weather conditions at the airport at the time of the observation? So first off, let's deal with weather conditions because that kind of narrows down our choices into like 2 of them. Okay, so what does this little symbol refer to, that thing right there? Well, that symbol is located on the bottom here, the present weather. Let me move my face out of the way again. It's this little smog symbol, and so we know that it has to do with smog, and that gets rid of 4 and gets rid of 2. Now we got to figure out the correct pressure. This number right here is a number that is less than 500. And if you remember the pressure rules, if it's less than 500, you add a 10 to the front of it. If it's more than 500, then you add a 9 to the front of this. So this becomes 1014.6, and that is the correct answer, number 3. Okay. Now, if you don't remember those rules, what I would suggest doing, and you can do this, I'll give you the chance to do this. If it's plus 500, you can write it right on your reference table, plus 500, then you go like this, you add a 9 to the front, okay? And you can write that rule right on there. If it's minus or less than 500, then you're going to add a 10. Okay, just so you know how to decode the pressure, you remember those rules. Now, again, just a reminder, and I talked about this the other day, that if you're not sure whether your number works, like our number ended up being 1014.6, check this out right here. Is 1014.6 on our pressure chart? Yes, it's right around here, okay? 1014.6 would be like right in this range. Is 914.6 on this? No, it's not, so it can't be the correct answer. Okay, so that's a good way to check your work. All right, what weather map symbol is associated with extremely low air pressure? Low air pressure is always lousy weather. Remember that, okay? Now, extremely low pressure would be like something like a really, really strong storm, a really, really, really lousy weather. And so this symbol right here is this one that looks like the spinning around thing. It's actually not on this present weather, but it's over here. See that? Hurricanes and tornadoes are like really, really bad, right? So this is a really, really strong hurricane, which would indicate really, really low air pressure. That's just something to know, okay? Hurricanes are really, really low air pressure. An air mass entering Alaska from the northern Pacific Ocean would most likely be labeled on a weather map as what? Okay, well, first off, Alaska is cold, so we know it's going to be polar. That gets rid of the tropical choices. Okay, and we know that it's coming from northern Pacific Ocean, so it's from water, which would mean maritime, not continental. So it's going to be number 3. Okay? All right, 23. Which type of air mass most likely has high humidity and high temperature? Okay, well, first off, high temperature is pretty simple. It's got to be tropical, so get rid of the polar choices. Now, high humidity. High humidity would be from a water source, right? Lots of water evaporating, going into the air. That's going to make it high humidity. So which one is from water? Well, that would be the maritime one, so that would be number 3. Okay? 24. Which station model represents a city with a relative humidity of 100%? Okay, so here's some review of some humidity stuff. 100% humidity means, well, number 1, there's going to be 100% cloud cover. It's either raining or snowing, or there's some type of precipitation coming down. Okay, so that gets rid of this choice because this one right here doesn't have any cloud cover. These other ones all do have 100% cloud cover, so that doesn't really narrow it down. But let's think about 100% humidity in terms of dew point and temperature. If the temperature and the dew point are the same, if they've reached the same number, then we are at 100% humidity. Okay, so dew point and temperature have to be the same. Now, if you look at this, temperature is this top left number, dew point's bottom left number. So if they're the same, it's 100% humidity. That would be choice number 2, and that's a really good one. Okay, now that actually goes all the way back to our stuff about dew point here. Okay, this chart on page 12. Remember, if the air temperature is the same as the dew point, then it's 100% humidity. These have 0 difference, which means there's 100%. Remember, these are all 0 difference is 100% humidity. So notice how these two numbers are the same, and if they're the same, it's 100% humidity. Okay, so that's important. All right, let's see. Number 25. The accompanying map shows partial weather conditions for stations A and B at 4 p.m. A weather front is located between the 2 stations. Okay, so we have this cold front in between them, and you'll notice that it is approximately 80, well, it is 80 degrees here at this station A, it's 65 at this station, which means the cold front already came through here. You'll notice that it cleared off too. Nice, like sunny conditions here. Okay, so it's cold, but sunny. A hasn't received that cold front yet. So what is going to happen to the temperature? Well, it's going to drop, right? As soon as that cold front gets there, it's hot, it's hot, it's hot. It's going to cool right down, okay? Presently, it's at 80 degrees Fahrenheit, so it can't be choice number 1 because that's starting at 85. Can't be choice number 3 because that's starting at 65. It's cooling down. It's going to stay cold, okay? So that's going to be number 4 for our choices. Okay. 26. Which sequence of events affecting moist air within Earth's atmosphere causes cloud formation? Clouds are formed by condensation. Remember that. Clouds, condensation. Okay? So that can't be number 2, and it can't be number 4. It's condensation, right? Condensation, condensation. It's got to be choice 1 or 3. Now, how do we make condensation? Well, we have to cool it down. Clouds, condensation, cooling. So which one has cooling in it? That would be number 1. Also know that when you have air rising, rising air means it's going to cool down. Rising air means it's going to become less dense and it's going to expand. And therefore, it's got to be choice number 1. Okay, so that's kind of related to our cloud stuff. 27A says using these conditions here, we're going to make a station model. Now, just a heads up, there is no way for me to really grade station models quite well, or and because you have to draw something, and that's hard to do on a computer. So just be aware that on your test, I'm never going to have you draw a station model. I'll have you interpret a station model, but not draw one. Okay, now if you drew this one correctly in your workbook, this is how you would do it. First off, it says that the air temperature is 65 degrees Fahrenheit, so I'm going to write 65 right there in the top left. The dew point is 53, so I'm going to write that in the bottom left. Okay, so that's the simple part. The wind direction is the southeast wind, so I'm going to draw a line to the southeast like that. And it says the wind speed is 20 knots, so I'm going to draw 2 long lines like that on there. Each line is 10 knots, so that's 20. Okay. Now it says that the barometric pressure is 1017.5. I get rid of the 10. Okay, so I get rid of that. I get rid of the decimal. So I'm just going to write 175 in the top right. Okay, and I think that's everything. All right, what is the cloud cover in this model? Well, it's a quarter shaded, 1/4 shaded. We would say that's 25% cloud cover. Okay, only partly cloudy skies. How would the pressure reading be shown on a station model? Well, we already did that. How do we show it? We write 3 digits, right? We just write the last 3 digits. Okay, I'm not going to write that because that would take a lot of writing, but we would just write the last 3 digits. That's how you do it. Okay. All right, 28. Again, another station model that you have to draw. Now, in this case, I would never make you do this because I can't, not at least in this virtual environment that we're in. Okay, so I'm going to draw this one for you. Let's start with the northwest wind. So I'm going to draw a line to the northwest. Okay, we're drawing a wind speed of 35 knots. That's 3 long lines. 1, 2, draw one in between there, 3, and then a short one for 5. Okay, so 35. Pressure is 1022.0. Get rid of the 10, get rid of the decimal. We're just going to write 220. 220. Okay. Cloud cover, 50%. So we're going to shade half of this thing. Doesn't matter which side is shaded. Okay, I'm just going to split it in half like that. Visibility, 5 miles. We're going to write a 5 right here. Okay. And then it says precipitation, 0.45 inches. That's simple. Just write 0.45 right there. And then finally, present weather. It's fog. Now, if you're not sure how to draw fog, it shows you right here on your reference table. Fog looks like 2 lines parallel. It's an equal sign, right? And we're going to write that. Technically, I should have written that on the inside of this. I'll squeeze it in there right there. There's my fog symbol. What is meant by a source region? Source is where it came from. So it's where the air originated, okay? I'm not going to write that all out, but the origin, okay, of the air. I'll just write origin because I don't like writing with a mouse, okay? But you get the idea, where it originated. 30A, what is the air pressure of Syracuse? Okay, in millibars. So the air pressure, remember, is this top right-hand corner number. Right now it is coded. We need to decode it. This number, as you can see, is less than 500. So we're going to add a 10 to the front of this. That's going to be 10, and then 0, 8, 8. Okay, and then all we got to do is add the decimal right there. You can kind of see it. There's my decimal, so it's 1008.8. That's the air pressure of Syracuse. Okay. Explain how the weather conditions shown on the station model suggest that Utica has the greatest chance of precipitation. You can say a lot of things here. Number one, 100% cloud cover. Okay, that's what I would write, 100% cloud cover. You could say that the humidity is really high because these two numbers are really close to each other. The temperature and dew point are really close. You could also say that the pressure is the lowest. It's 999.8. Okay, so the pressure is low. The temperature and dew point are close. The 100% cloud cover, whatever you want to write there, it's good. Okay. All right. Which city has the lowest air pressure? Well, I just told you. It's Utica. And you have to figure that out just by looking at the numbers and decoding them all. Okay. In this case, the biggest number is actually the lowest number when it's coded, which is kind of confusing. You have to decode it. That's 999.8, and therefore that's the lowest pressure. This is 1001. This is 1008. That's 1020. Okay. What was the barometric pressure for Niagara Falls 3 hours ago? This is a tricky problem. Okay, so let's talk about this a little bit. First off, what is the pressure currently? Well, it's 1020.1. Okay. Now, this shows you the trend. What this says is it's gone up 1 millibar. You have to add the decimal in there. 1 millibar over the last 3 hours. So what was it 3 hours ago? Well, it was 1 millibar less. So we have to subtract 1 millibar from this. We actually do the opposite of what it says here. It's gone up 1 millibar. We have to go back. So go back 1 millibar. That's going to be 1019.1. That's a tricky question. Okay. New York City was experiencing a wind blowing from the south at 10 knots with hazy conditions, limiting visibility of 3/4 of a mile. In the station model for New York City, draw the information. Okay, so we have to add some stuff here. Okay, so let's think about this a little bit. We have to draw, place in the proper location, and format the information below. Okay, so wind direction was from the south, so I'm going to draw a line to the south like that. Wind speed was 10 knots. Okay, and 3/4 of a mile visibility, so 3/4 we're going to write right there, 3/4. Okay, hazy conditions. Haze looks like this. Here's the haze symbol on this chart. Right here it looks like a figure 8. Okay, I'm going to draw that in here as best I can. I can't really draw, and I think that we got it all. Okay, cool. F. Give the full barometric pressure reading from the above station model. Full barometric pressure. So we got to decode this thing. It's less than 500, so we add a 10 in front. That's 1001.2 millibars. Okay. We add the decimal in between the last two. All right, last page. This is going too long. Let's talk about the orographic effect again. So this is related to climate. Windward side over here, it's kind of hard to see my picture. Windward side, where the breeze is blowing up the mountain. Okay, so it's cold air over here, and then it's coming down the other side, it gets warm again. Okay, so it's colder temperature. So we're going to write colder we're talking about location X. So it's colder at X, coming off the water, going up into the mountain, so it cools off. Condenses, forms clouds, precipitates, lots of rain over here. So water vapor content is much higher. It's wetter conditions. It's really rainy all the time. Think Seattle is the windward side, okay? So higher water vapor content. Okay, 32A. Explain why the warm, moist air is rising at the frontal boundary. A lot of things you could say here. Number one, warm air and moist air is less dense. So I would write less dense. That's a really good answer to that question. Very simple, right? It's less dense, so it rises. It's also being pushed upward by that cold air mass, which is going underneath of it. Cold air sinks down and stays low and pushes this warm air up, wedges its way underneath of it. Okay? State 1 process that causes clouds to form in this rising air. You could say a lot of different things. I would say number 1, it's cooling off. Okay? Why is it cooling off? Because it's getting pushed up higher into the atmosphere, and it cools off as it rises. You could say condensation, right? Condensation is another great word that relates to clouds. Those C words are big. Cooling, condensation, clouds, okay? And that's important. You could say that the air is expanding and it's becoming less dense, okay? Lots of things there. All right. 32C. Central Canada was a geographic source region for the CP air mass shown in the cross section. So this is from Canada. Identify the most likely geographic source region for the MT air mass. Okay, so MT means maritime tropical. Where could that possibly be from? All right, if we look back at this map before, just to go back to North America a little bit here, this is Canada. This is like a warmer tropical region down here. Okay, so we're probably thinking like somewhere down the Gulf of Mexico, maybe. Okay, and it's maritime, so it's got to be from a source region in the water. I'm going to say Gulf of Mexico. You could say from the Pacific, Southern Pacific. Okay, Gulf of Mexico is good. Okay. When the cold front passes, what will occur to the barometric pressure? This is dry air. Okay, cold, dry air. Because it's cold, dry air, dry equals high. Remember that. Okay, the pressure is going to increase a lot. That's going to clear off the skies. It's going to be pretty sunny, but it's going to be pretty cold. So when the cold air mass comes through, you often have high pressure afterwards, so that it's going to become higher. Okay, higher, or it's going to increase. Okay, if you want to say increase there. All right, 33A and B. These are always fun. Okay, emergency preparedness. How do you prepare for danger from a hurricane or a tornado? Okay, first aid kit is for some reason everybody's first choice. Cool, that's fine. Yeah, you could say that. Okay, board up your windows for a hurricane. For a tornado, make sure you know where to go to your lowest part of your house. Okay, so just kind of like what do you do in this situation? Have a plan. Okay, of where you're going to go. Have backup food, maybe a generator for electricity, because that's going to happen afterwards. Okay, so there's lots of things you can say. For a hurricane, you want to go to the top of your house after, when flooding comes, okay, or the middle of your house during it. Okay, you board up your windows. Tornado, you go to the lowest level. So that's pretty much it. Okay, last question. Describe one surface condition or atmospheric condition that makes the area over the Atlantic Ocean between 10 north and 20 north ideal for hurricanes to form. Well, notice the latitude is really close to the equator. So we're talking really warm water. Okay, so warm oceans tend to lead to lots of evaporation, which is going to add a lot of moisture to the air, which is going to lead to hurricanes forming. Okay, lots of evaporation as a result of that warm air. Okay, I'm going to write evap. All right. You could also say that because it's near the equator, it's experiencing lower pressure, because low pressure is where the air is diverging, right? Converging, I should say. You have converging air, and that causes low pressure. All right, so that's a possibility too. But again, the big thing is the warm conditions in that region. All right, so that's pretty much it. I would suggest going back and maybe even doing this first section and looking at your answers in the book, checking those over. And if you have any questions about anything, don't hesitate to ask. We're going to have some review today during the Zoom session as well. Okay.